Cache memory mapping functions and replacement algorithms. My name is Tunjiro Susan and I'm presenting the cache memory mapping functions first, which there are three in number. We have direct mapping, we have associative mapping, and we also have set associative mapping. For the cache memory mapping functions, these determine how data is mapped into cache blocks, and like they determine because cache the number of main memory blocks are more than the number of the cache lines. Here, in the direct mapping, this technique, one a block of main memory is mapped exactly to one possible cache line. This is by dividing each line in the memory it stores, like deduces that each line of the cache memory stores one block. And in here, like how it is direct as it is. One block is mapped exactly to one cache line. And then, as it shows here, this T represents length of block in bits, and B also, like B represents length of block in in bits, and T represents length of tag in bits. Here, the next one, we have the associative memory. This overcomes the disadvantage of direct memory, permitting each main memory block to be loaded into any line of the cache it wants. So this block, you see, like we have here, one block can be mapped into different cache lines. It is so flexible compared to the direct memory. Remember that direct memory, it has to be one block, one line, but here one block can be loaded into different lines. Associative mapping, still the address has to be main memory address has to be in binary, and the other data can be in hexadecimal. Then we have the set associative mapping. This set associative mapping has both the factors of the direct memory and also the factors of the set associative mapping, and plus the what this set associative mapping solves the danger of the associative mapping, the disadvantage of the associative mapping, where it causes Nanka cache misses, like the conflict miss. So here in the set associative mapping, one block can be mapped into different sets. In the cache memory is divided into different sets, like we see here. So each block is mapped into different cache lines of sets. So that's what I have to say about the cache memory mapping functions. And in here we have the replacement algorithms. For the replacement algorithms, they help to know which line is being replaced, which block is being replaced in case the line is already full, or the cache is already full and you have some other data to also load in. So here we have the list recently used, which is the LRU. This policy explains temporary locality principle. This means the block which got accessed lately is likely to be accessed in the near future. Therefore, this placement policy evicts the least recent used block inside the cache. So here is the blocks in the cache. Sorry, I didn't put the arrows, but here B is the one that was there first, C then A. So if I have another data which is D, like to enter, I will have to remove the B. I have to remove the B because this time the B is what is the least recently used. So I'll remove the D and replace it with a D. Then the next we have first in, first out. As it is, first in, first out. If the cache is loaded and I still have data to enter. So I'll remove the one that was there first, which is B. So I'll evict B, replace it with F. Then for the least frequently used LFU, this policy evicts the least frequency referred to block in the cache. Remember the frequency B is recorded, like it is being recorded every time. So which one was what? Each one, the frequency is showing on each one, but D and B have the same frequency. So I'll have to evict B so that I can remain with D since they are the same, but it was the first to be there. So I'll just remove the one that was first entered before the other. That is all about the replacement of algorithms. In conclusion, this mapping and functions and replacement algorithms work together to optimize cache performance by reducing the time it takes to access frequently used data based on the access patterns of the programs running on the processor, the choice of which to use depends on the specific requirements and constraints of the system. Thank you. My name is Tol Tunjire Suzanne.